Okay, so we have been talking about one-dimensional arrays. I think we have talked a lot about it. Now it's time to move on to bigger and better things, the two-dimensional arrays. So it's like an array of arrays. It's like a table inside an Excel with rows and columns. We have been just dealing with either a bunch of, not a bunch, either rows or columns. But now we are basically having an array which has rows and columns. So, like the 1D or one-dimensional array, here we also have to use subscript to identify any element inside the array. Since there are rows and columns here instead of just columns, we have two subscripts: the row subscript and the column subscript, and they are also zero relative. Like they start off, the first item is a 0, not a 1. And like the one-dimensional array, we refer to an element using the name followed by uh, the row column subscript pair in parentheses. And there's an example shown at the bottom where the first item, like the first item meaning the leftmost top or the top leftmost item, has 0 0, the first row and the first column, and it goes from there. The bottom row has 3 0 because this is a 4 by 3, meaning that it has rows and 3 columns. So the highest subscript for the rows is 3 because it starts from 0. The highest subscript for a column is 2 because it starts from 0 again. So uh, just what I said, that highest row subscript and highest column subscript are zero relative. Number of rows is equals to highest row subscript plus 1, and same goes for columns. And like 1D arrays, we can specify initial values. If no values are declared, array elements are already initialized. Zeros for numbers, empty strings for strings, and false for boolean. So here's some examples of how to declare. It's very similar to one-dimensional array, except for the fact that we have to declare, if we are just declaring the number of elements, we have to declare the highest row subscript and the highest column subscript. And also we have to declare the data type. Or we can leave out that part. We can just have two parentheses and a comma inside. We remember, in a 1D array we didn't have to put anything between the parentheses if we are already putting in initial values. But since there's a row and a column here, we need to put the comma, and then as data type, put in the data type, and then equals to whatever initial values we want, separated by commas. uh, Now, in each row, we have to put the braces. So within, there's going to be braces inside braces if you're trying to initialize the array. So the example 3 gives a good idea of that, where the user has initialized the array, and so in each set of braces, is each row of your array, then separated by a comma, and that's the next row. It goes on like that. uh, Coming back to example 1, that's just saying that we are declaring a 50 row 4 column array, and that's why there's a 49 and 3. And the example 2 is very similar to that. It's just from a string we got to integer. Example 4 is very similar to example 3. In example 3 we were talking about strings. In example 4 we're talking about numbers, a numeric array. So how to store data? Well, if you're just storing one by one, you have to specify the row subscript and the column subscript, and then you can assign data to it. If you can also use nested for loops to do this, and using that you can basically put in a bunch of data to the array. And so example 2 and 3 give a perspective to that. So we are using a for row loop and a for column loop, and inside these two loops, there's what we're doing is adding the number 1 to the contents of each element in the totals array by doing the two loops. And in example 3, what we're doing is that we are again doing nested loops, nested do while loops. So the outer loop is the row loop, the inner loop is the column loop, and basically what we're doing is that um, we are increasing the content of the element of the prices array by 5%. So that's why we're multiplying prices, the specific row column, by 1.05. So whatever the initial value was, it's getting multiplied by 1.05, which is 5%, and then getting stored. And then we have that column plus equals to 1 and row plus equals to 1 to keep incrementing the columns and the rows. Similar to 1D arrays, we can get the upper bound for the row and the column, meaning that what is the highest row subscript and what is the lowest row or the highest column subscript by get upper bound. And if it's 0 within parentheses, that means that it gets you the highest row. If it's 1 bit within the parentheses, that gives you highest column subscript. And we have examples to show that. So how to go through a two-dimensional array? Well, we will use nested loops, which we saw before. The outer loop will track the row subscript, the inner loop will track the column subscript, and we can use for each next loops to do this. Here's an example where first we have defined an array called months, having the first column is the name of the month, the second column is the number of days in that month, and then we have the high row and high column to get the upper bounds, and then we have a for loop so that it keeps on adding items to a list box from the months array. So it displays the contents of the month array in the list box, and the contents are displayed row by row as shown in this illustration. So here after each row there's or after the month name there's a number of dates. So it's not listing as an array, it's rather listing row by row. So in an array it was January, then 31, February 28, March 31, like that. But since you cannot do that in a list box, then you have to do it like that. And example 2 is kind of the same thing. It's just that first all the months are displayed, and then the number of days in that are displayed using a do while loop. And so what's gonna happen is something like this. First all the months are displayed and the corresponding days in each month are displayed.